Good morning, everybody. Today I'll teach the DMA controller. It's 8257. 8257 DMA controller. Let's start. 8257. Here DMA stands for Direct Memory Access. It is designed by the Intel people to transfer the data at very faster rate, and it allows the data transfer. It allows uh, the data transfer directly to or from the memory without any interference of CPU. What here, if you want to transfer the data to the computer or an external node, it is very much necessary. There is an involvement of CPU is required, but uh, at the same time, CPU has to perform many other functions to function according to our user requirement. So already CPU is engaged with many other works, and again you are transferring data to the computer systems, or data is collecting from the computer system. It's very much difficult to involve every time CPU in this process. So that the Intel is came up with a very new idea, that is the 8257 IC integrated circuit, saying DMA controller. And DMA controller is the direct memory access without any interference of CPU embedded in it. So using DMA controller, a device requests the CPU. DMA controller, this using DMA controller, this device requests the CPU to hold the data, to hold its data and address control bus, and so the device is free to transfer data directly from memory to memory. The DMA data transfer is initiated only after HLDS signal is from the CPU. So what happens here? In this DMA controller, DMA request will send to the CPU. Now CPU acknowledges after allocation of all address bus, control bus, and to hold the CPU data. After holding CPU data, and these control bus, address bus, and data bus will be handed over to the DMA controller. Therefore, here the transfer takes place. Here, data transfer will takes place at this. First, we send the request signal to the CPU, and CPU send a request acknowledgement signal to the DMA controller. That acknowledgement is HLDS signal, hold acknowledgement signal. Already the data is held in a CPU, and that acknowledgement is sent to the DMA controller. Now, a DMA controller will start its process to transfer the data from external world to or to the computers. The data transfer will be takes place. So, the first in the DMA operations, basically what are the main important basic steps are required while transferring data from external world to CPU or CPU to external world. First, I'll explain the steps which are required to transfer the data. What are the operations has to be carried out while performing data to be transferred? The first one is, in first one, what happens initially when a device has to send the data between a device and a memory, the device has to send DMA request. DMA request. First, DMA controller has to send DMA controller has to send request signal to CPU, and this request signal is called as DRQ. DRQ signal is nothing but a DMA request signal to the CPU. when any device has to send a data between device and memory, the device has to send a DMA request to DMA controller. And DMA controller sends code request to CPU and waits the CPU, uh, waits for the CPU. Once DMA controller sending a request to the CPU, what a CPU will do? CPU hold request. Uh, Here, this CPU waits until CPU asserts, until it asserts or it gives, it waits until HLDA signal, hold acknowledgement signal, to the DMA controller. Then microprocessors tri-states means high impedance to the all buses data bus. After this HLDA signals, uh, microprocessor or a microcontroller, whatever it is, microprocessor. If it is CPU, microprocessor uh, tri-stated, tri-stated all the buses. Tri-stated means high impedance to the all buses, data bus, address bus, and control bus. All these buses are high tri-stated. Then the CPU leaves the control. CPU handed over the controls. CPU handed over the control over the buses. Acknowledges to the hold request through HLDA signal and handed over to the DMA controller. Now CPU is in hold state. CPU is in hold state, and the DMA controller has to manage the operations over the buses, uh, between CPU, memory, and external devices and external IO devices. And this is the first what happens. Initially, it sends the DMA controller sends the hold request to the CPU, and CPU asserts HLDA signals until it holds all the control buses. Then the microprocessor tri-states all data buses, address buses, and control buses. The CPU leaves the control over the buses and acknowledges the hold request through HLDA signals to the DMA controller. Now the CPU is in hold state. Now the DMA controller has to manage all the operations over the buses between CPU, memory, and IO devices. Okay, all tri-stated buses will be there. All these control over all these buses will be handed over to the DMA controller, and what DMA controller has to manage the operations. The features of now we'll see the features of 8257. Features of 8257. Features of 8257 are, first one is it has 4 channels. 4 channels will be there. 4 channels. 4 channels, and which can be used over 4 IO devices. 4 IO devices, 4 channels will be there. So 4 IO devices can be used over 4 IO devices. And second, the feature of this is each channel has 16-bit address. 4 channels are there. Each channel has 16-bit address and 14-bit counter. 14-bit counters will be there. Third important point is each channel can transfer up to 64 kilobytes of data, 64 KB bytes of data, and each channel programmed independently. Each channel programmed independently. And each channel can can perform read, transfer, write, transfer, and verify transfer operations it generates mark signal to the peripheral device that 128 bytes has been transferred. So every 128 bits of receiver or transfer, 128 bytes of transfer of data, the one mark signal will be sent to the DMA controller. It requires a single phase block. Its frequency range from 250 to 3 megahertz, and it operates in two modes. One is a master mode, another one is a slave mode. And now see what is master mode and slave mode means. Master mode, slave mode is when a DMA controller is asking a request, sending a request signal to the CPU, and until CPU sends HLDA signals to the DMA controller, and up to this process, right? Until HLDA signal reaches to the DMA operation, until control until this signal, this CPU is under a slave mode. Now, when a data transfer takes place between DMA controller and CPU and GPU, memory and data transfer between memory takes place. That process is called as a master mode. Now we'll see the block diagram. Block diagram of 8257 controller. Here, it has a data bus buffer. See, this is the data bus buffer, and next one is a read-write logic control and control logic. And this is 4 channels will be there. Is channel 0, channel 1, and channel 2, channel 3. Each has a 16-bit address, 16-bit address, and counter will be there. And this counter is a 14-bit counter. Everyone has a 14-bit counter. Here, one a priority resolver will be there, which decides which channel has highest priority and which channel has a lowest priority. And each and every channel will have request signals. Here, what if while data transfer, DMA controller has to send a data request, direct memory request to the DMA request inputs will be there. So therefore, each and every channel will have one request. This is a channel request for channel 0, a request for channel 1, channel 2, and channel 3. So therefore, similarly, acknowledgement 0 and acknowledgement 1, 2, and 3. And there are many other data pins and D0 to D7. I go on and we'll see one by one what is the pin required, what are the pins, what are the functions of these pins individually. And the pin number 1, first one is DRQ node to DRQ node to DRQ3, and 4 channels will be there and 4 requests will be there. These are the 4 individual channel DMA request pins which are used by the peripheral devices using DMA services, which are used by the peripheral service devices for using DMA services. When a fixed priority mode is selected, the DRQ node has the highest priority, and DRQ3 as least priority. And next, another pins are DACK node, acknowledgement signal 0, and DACK3. These are the acknowledgement signals. These are active low DMA acknowledge lines, which updates the requesting peripheral about the status of their request by CPU. These lines can also act as strobe lines for the requesting devices. And next one is D0 to D7 pins. These are bidirectional data lines which are used to interface the system bus with the internal data bus of DMA controller. Function of D0 to D7 is a data line which are used to interface the system bus with the internal data bus of DMA controller. In slave mode, what happens in slave mode? It carries command words to 8257. The status word from 8257 and command words and status words. Status words from 8257. Command words to 8257 and status words from 8257 under slave mode. And under master mode, what happens is these lines are used to send higher byte of generated address to the latch. This address is further latched using add address strobe signal. So here in master mode, what happens are these lines in master mode D0 to D7 lines are used to send higher byte of generated address to the latch. This address is further latched to add strobe signals. Next line is next pin is IOR. And these are the pins which are same can be available in pin diagram of this 8257. And it is also an active low signal. Active low is a bidirectional input line which is used to CPU read internal registers of 8057. It is used, IO read means is used to read internal registers of 8257 in slave mode. Whereas in master mode, it is used to read a data from the peripheral devices. In master mode, master is used to read data from peripheral devices during memory write cycle. And next one is IOW is write the data. It is also active low bidirectional input output signal, which is used to load the contents of data bus to the 8-bit mode register or lower upper byte of 16-bit DMA address register or terminal count register. In master mode, it is used to load the data to the peripheral devices during DMA read cycle. It is used to load the data to the peripheral devices during DMA memory read cycle. And IOW is active low bidirectional signal, and which is used the contents which is used to load the contents of data bus to 8-bit mode register or lower and upper byte of DMA at 16-bit address, DMA 16-bit address register or terminal count. First, it it is you in slave mode. What happens is in slave mode, it is used. It is used to load the data. To load the data bus to the 8-bit mode register of 8257 or lower or upper higher L by H lower byte of 16-bit DMA address. 16-bit DMA address register or terminal count register. Whereas in master mode, what happens is load the data to the peripheral devices. Load the data to peripheral devices using memory read. Using memory read cycle. Next one is clock signal. Clock. The function of clock is clock frequency signal, which is required for internal operations of 8257 or 5 synchronization. And next one is a reset signal. A reset signal, its signal is used to reset the DMA controller by disabling all DMA channels. By all DMA channels, we have one reset signal is required to disable all DMA channels. And next, A0 to A3, these four least significant address lines. These are least significant address lines. These lines under slave mode acts as input signals. Under slave modes acts as input signals, which selects one of the register to be read or written. These registers, these lines, four lines, A0, A1, A2, A3, selects one of the registers to read or write the data. In master mode, in A0 to A3 lines, in master mode, what happens? In master mode, they are four least significant memory address output lines generated. These are the input lines under slave mode. In master mode, they are four least significant memory address output lines generated by 8257. Very important, and each and everything. Let's try to explain all the points. And another important line of 8257 is CS. This CS is a chip select line. Is an active low again. Whenever whatever the active low line signal will be there, this complement will be there in pin diagram of this 8257. Under this chip select line, under slave mode, what happens in slave mode? In S mode, S means a slave mode. It enables a read-write operations. Enables read-write operations. Whereas in master mode, it enables all read-write operations and disables all read-write operations. Next, as A4 to A7 lines are there, these four lines. These are higher nibble of lower byte address generated by DMA in a master mode. These are higher nibble. First A6 16-bit address A0 to A15 will be there. A0 to A3 already we discussed. This is the functions of uh, in slave mode. It acts as an input which selects one of the register to read and write to write the data. In master mode, these are used as a lower nibble of significant memory output lines generated by 825. In A4 to A7 lines or higher nibble of lower byte address generated by DMA controllers. This is a least nibble, and this is a lower nibble of higher nibble of lower byte address generated by DMA under master mode operations. And next one is a ready signal will be there. This ready signal is active high asynchronous input signal which makes a DMA ready by inserting wait state. And this it makes ready by inserting a wait state. And next one is a HRQ signal will be there, or HRQ pin. And this signal is used to receive the hold request signal from the output devices. In slave mode, it is connected with the DRQ input line in 8257, whereas in master mode, it is connected with the hold input of CPU. And next one is HLDA. This is a hold acknowledgement signal. Hold acknowledgement signal which indicates DMA controller has the DMA controller that the buses has been granted requesting peripherals by the CPU when it is set to 1. Means all the control bus, data bus, and address bus, all these controls over all these buses will acquire by the DMA controller when HLDS is received. And next one is a memory read, MEM, or this it is the low memory read signal which is used to read the data from addressed memory locations during DMA read cycle. DMA read cycle. Next, memory write. This is memory read is there, right? Next one is memory write. This is active low signal. Again, this is active low signal, and three-state signal which is used to write the data onto the address memory locations during a during DMA write operations. And ADST is another signal which is used to convert high byte of memory address generated by DMA controller into a latches. And next AEN signal will be there. AEN signal. Let me show on this. This AEN signal will be there. This signal AEN signal, and this AEN signal is used to disable address bus and data bus. This enables the address bus and data bus of 8257. And next one, TC is there. The TC is terminal count, which indicates the present DMA cycle to the present peripheral devices. The terminal count, so each and every channel has a counter, 14-bit counter will be there, and it is a terminal count on which 8257 is presently will be fixed. That status will be indicated with a pin of TC. And next one is a mark signal is there. This mark will be activated after each 128 cycles or integral multiples of 8, 128 or 128 of integral multiples of 128 from its beginning. Then it indicates the current DMA cycle is the 128th cycle since the previous mark output to the selected peripheral devices. And next one is a VCC is there. This VCC is a supply line is required. This is a signal which is required for the operation to be secure. And this is all about each and every pin of block diagram of 8257 as well as a pin diagram of Let me show the pin diagram. Where I'll insert here. Insert the picture. I downloaded already. It is present in my A257 pin diagram. This is a pin diagram of 8257. Here, I explained each and every pin, IO or IO write and IO read, IO read, IO write, memory write, on signal after every 128 bytes of cycles. This will be activated or integral multiples of 128, and ready signal will be there. It makes the 8257 ready by inserting a wait signals. HLDA, as I already explained, HLDA is uh, HLDA is a hold acknowledgement from the CPU to 8257. 57. So that's why whenever this signal is received to the 8257 controller, now 8257 controller acquires all controls over uh, control bus, data bus, and address bus of CPU. All these controls will be managed by this 8257 when HLDA signal is reaches to the 8257. Add strobe signal, and this is address strobe, and this signal will be used. A4 to A7 signals will be used for add strobe signal. AN is enable address and data bus enable signal, and this HRQ is a hold request sent to the CPU from 8257. Chip select line is when chip select line under master mode, chip select line, all operation read write operations will be disabled, whereas in master mode all will be disabled. And clock signal is required for internal operations of 8257. Reset signal, to reset all channels we use this reset signals. And data acknowledgement, DMA acknowledgement 2, 3, and DMA acknowledgement already I explained, and these acknowledgements from, and where are DRQ, DRQ not, and these 4 requests from to the 8257, and requests sent to the from the external peripheral devices, from external peripheral devices to the 8257. Now 8257 sends the signals to the CPU. Like the ground signal is required, very much required to get on or off. And these 4 are higher nibble of lower order address generated by the 8257. And TC is a terminal count, which is indicates the status of each and every individual channel terminal count. And A3 to A0 is A3 A0 is used. What A3 A0 is? These are least significant address lines. In his slave mode, it acts as input, which selects one of the register to be read or written. Okay, it's a mode set register and address register, data register, whatever the is select. It acts like an input and a slave mode. Whereas in master mode, they are least significant memory address generated by 8257. And VCC is required for a supply voltage, and D0 to D7 pins or data pins. D0 to D7 pins or data pins, which are used to transfer the data from 8257 to CPU or external devices like that. And this is all about a pin diagram of 8257. Block diagram and pin diagram of 8257. And I explained the operations, what are the procedures required to transfer direct memory transfer data from memory to the peripheral devices. And next one is what features of 8257. After that, a block diagram of 8257. Next is the pin diagram of 8257. By this, I complete total 8257 concept, DMA controller.